either basic quantities, that is length, mass, time, current electricity, thermodynamic temperature, luminous intensity, and amount of substance. These are all the fundamental quantities. The SI unit of mass is kilogram. So now we are going to see about the mass. So you know that is a beam balance. Ordinary beam balance is used for measuring that mass. So and this is for the mass which is placed in a Paris, that is 1 kilogram stone. So this is the prototype of kilogram. So using this prototype, we are making all the 1 kilogram of stone. So it is placed in the Paris. So it is made up of platinum iridium. National Physical Laboratory. It is placed in the National Physical Laboratory in Paris. Okay. So these are all the example for the weight. Then 1 quintal equal to, you know that is 100 kilogram. 100 kilogram. So 100 kilogram is represented of 1 quintal. And these are the very large, really large values. That is 3 times. That 3 times means 3 into 1000. That is 3000 kilogram. That much of weight only placed in that very large container. So these are the instruments are used to measure the smaller value to the larger value. That the first one is the electronic weighing machine. That is used for measuring the very accurate value. That is used in the jewelry shop. Common balance. It is used for the grocery shop. You know that. Then last one is platform balance. That is used for the very large values. That is used in the godown to measure the greater mass. So these all the things are used to measure the mass. And solar system, atom, and we can measure the mass of an atom. At the same time, we can measure the mass of the solar system. Solar system is a very large in mass. Atom is a very small in mass. So by using that mass, we can measure the very larger value and very smaller value, like the length. Okay. So you can measure the very large value and the small value. So by using Newton's universal law of gravitation, every particle in the universe attracts the other particle's force. It's directly proportional to the product of their mass and inversely proportional to square of the distance between them. So already you know that you studied in the 10th standard. So Newton's universal gravitation law. So using that we can measure the distance of the planet. And this is the mass spectrometer. It is used for measuring the very small mass, atomic mass unit. So in mass spectrometer, we are using the electronic beam that is used for magnetic and electric plates, that is using magnetic and electric field. We can measure the mass of an atom. So the mass spectrograph is used for measuring the mass of an atom. So using that, we are arranging that element in a periodic table depending on the atomic mass. So there is a uses of mass spectrometer. By the deflection, we can change the direction of the electron beam. That is shown in the picture by using the electric and the magnetic field. So first standard, you are going to study in that in detail. The next one is the size of an atom. The size of an atom is very, very small. By using the mass spectrometer, we can measure the mass of an atom. Okay, that proton, electron, and neutron, and mass of an atom. So everything is calculated by using the mass spectrometer. Okay, that is mass spectrometer. So unified atomic mass unit is taken as a letter small u. So that is called unified. So one unified atomic mass unit is defined as the mass of 1/12 of the isolated atomic of carbon-12 at rest in its ground state, including the mass of the electron. Already we know that atomic mass unit 1 AMU equal to 1/12 of the carbon atom, or that is 1 U equal to 1.66 into 10 to the power of minus 27 kilogram. So these are all the objects which have a very low mass and greater mass. See that 10 to the power of minus 3 to 30. That is smaller mass. From 10 to the power of 2 to 10 to the power of 55, it's a very greater mass. For example, for that smaller mass is electron, greater mass is sun. Then these are all the laws which discovered in that year. In 1666, universal law of gravitation. 1879, electric bulb. 1905, special relativity theory. 1935, neutron. 1986, superconductors. Then now we are going to see the measurement of time. So measurement of time is a very important thing. So after measuring the mass, is a measurement of time is very, very important. So suppose somebody is running, you know that running this, we have to tell that who is first, second, third. So depending on the time period only, we can able to classify that who won the first and second and the third. So we have to measure the time period accurately. So how to calculate the time period? By using that ordinary watch, you are not able to calculate that accurate value of the time period. So we are not able to use that ordinary watch. So we can use that accurate watch to measure the exact time period, and that everything is has a small error. Okay, so without error, we can take that stopwatch. So using that stopwatch, we can measure that accurate time period. So it's an instrument to measure the time period. So these are all the instruments used for measuring the time. So first one is a sand clock, another one is a pendulum, then last one is the sundial. So these are all the instruments are used to measure the time period in older days. So nowadays we are using the stop clock and other atomic clock, like that type of instruments are used to measure the used to measure the time accurately. So it's a periodic table. So cesium atom. That cesium atom is used in the that is used in the atomic clock. So using that cesium clock, this is called atomic clock. That atomic clocks are used to measure the accurate time period. That second 1 second is already we know that the time needed for that this much of vibrations of the radiation corresponding to the transition between the two hyper fine levels of the ground state of cesium 133 atom. So we are taking the cesium 133 atom. The transition time period between the two orbitals, that one orbital to another orbital, it is vibrating between the two orbitals. That time period is taken as this much of vibration occurs. So in that we can calculate the time period. So this is the energy stored in the clock. That is, that clocks are used in that afterwards. Not this is for atomic clock. It is used to measure the very accurate time. So cesium 133 is used for that to measure the atomic clock. So also uncertainty of the atomic clock, that is error. That is 1 into 10 to the power of 13 seconds. So that much of the seconds, that's only 1 second is occurs in error. So இவ்வளோ செகண்ட்ஸ் ஓடிச்சு அப்படின்னா ஒரு செகண்ட் வந்து அதுல லாஸ் ஆகும். So 3 microseconds per year. Per year, it will error is 3 microseconds. Okay. So these are all the measurement of the National Physical Laboratory. They calculated that in atomic clock 3 microseconds per year. Only microseconds, not equal to second. Microsecond. So that gives time interval. So from 10 to the power of -1 to 10 to the power of -24 is the shortest, very small time period. 10 to the power of 2 to 10 to the power of 7 is a very greater time period. So the lifespan of unstable particle, radio wave, these are all the small value. For large value, you can take age of an Egyptian pyramids, age of the universe, and these are all the things are very large in values. So using the time period, we can denote the very small value. At the same time, we can explain in a very large value. Okay.